Alrighty, so this is going to be homework 1 Part A, and we're going to be simulating the flow of 3 tanks. So for this is going to be Q in, which is the flow in. This is going to be Q1, which is flow 1, or the flow from tank 1 into tank 2. This is going to be Q2, which is the flow from tank 2 to tank 3, and then this is going to be Q3. Now, for the cross-sectional area, I'm just going to label that as A, and this will be H, and then H. So, let's think, where do we want to start? I guess first I'll start with the initial H value. So the initial H value is going to be a function of the cross-sectional area times the difference in the height with respect to the difference in time, and that's going to be equal to the flow rate in minus the area of the hole. So this is going to be the flow rate out. So the flow rate out is going to be the area of the hole 2 GH. Yep. So then from there, we can go ahead and move the A over. Times square root of 2GH 1 over AC. And then the final H naught value is going to be equal to, when we take the derivative of this, and that's going to be equal to Qn over AH, the area of the hole, squared, times 1 over 2 times G. And G is the force of gravity. So now we can do the Q values. So Qn is going to be a set value, so we won't bother with that right now. But Q1 is going to be equal to the area of the hole, so this right here, and all the areas of the hole are the same, and that's going to be times square root of 2GH. Q2 is going to be equal to, well, H1. Now Q2 is going to be equal to AH square root 2GH2, and then Q3 is going to be equal to AH times the square root 2GH3. And then we have our 3 equations for the flow. Now we have to find the equations for the height, which are actually going to be volume, essentially, because it's going to be the change in height over the change in time. That's incorrect. It's not a reference of volume. But anyway, it's going to be Qn for the first height. It's going to be Qn minus Q1 all over A, which is the cross-sectional area, but we'll just leave it as A. dH2 dt is going to be equal to Q1 minus Q2 all over A. And then, let's see, where do we have a little bit of space here? We can pretend that this is all erased. Really, all we need is this from here. So forget about that. dH3 over dt, which again is the change in height with respect to the change in time. It's going to be equal to Q2 minus Q3 all over A. And yep, those are all the equations that we're going to need. Yeah, alrighty. Time to get to the coding. And this is just my phone case. But anyway. Let's share. And then we are going to share this. Let's change it so that my video is a little bit bigger. I believe it's that. No. That. I had it a fucking hour ago. Yeah, it's a bit ridiculous. Shoot. Sorry if I seem a little bit stressed. I've had a not great day. So I literally had it 15 minutes ago. So this is awesome. Well, let's just say that that's big enough. Now it's not even showing it at all. Let's just stop sharing and then start sharing again. I gotta share that. And then, yep. Perfect. Oh, there we go. Wonderful. Put that up there. Kind of keep this down to the side. Alrighty, for our H0, we determined that that was the QN naught, which is just the initial QN value. And then that is going to be over a H. And then that is going to be squared times, divided by 2 times G. And as you can see, I already put in all the values just so I wouldn't have to be looking back and forth between the pages. All right. So next, we are going to define the right-hand side. And that's going to be with respect to time and volume. And then first we'll just do this. Like I said, since it's dH/dt, those are really kind of forms of volume. The heights are in reference to volume. So now we're going to put in our Q value. So Q1 is equal to AH times the square root of 2 times G times H. 1. Looks right to me. And then we can just copy and paste this since Q2 and Q3 are the same equation. And I apologize if it seems like I'm rushing through this. Just not a great day. So we are going to want to return the array, which it's an array just because we have 3 equations and we need 3 outputs for those equations. And that's going to be our H values, which we saw was Qn minus Q1 divided by A, which is the cross-sectional area of the entire tank. And then, just like we were on the board, Q1 minus Q2 divided by the area of the tank. And then, again, Q2 minus Q3 divided by the area of the tank. Shift enter. I don't know if I ran this one. There we go. So now we're just gonna set the end time, which I have found that a good end time is 4,000 seconds. So I'm just gonna put it as 4,000. And then as a result, we want to do solve underscore IVP. And then for that, first we're going to tell it what to solve, which is the right-hand side, which we defined up here. And then next we're going to give it a time value. So it's going to be 0 to the t end, which is the end of the event that the equation is talking about. And then we're going to do an array and p dot array. And then since these are all starting an initial steady state, we're going to go ahead and just put those all as h naught. And then since output equals true. And then the method we're going to use is radow, because I've been told that that is the most powerful method of calculating this. So Shift Enter. What did I do wrong? Alrighty, let's see. What have we got? It's the same way I've written it all day. What did I do wrong? Fix error. Let's see. Don't know what it even changed, but cool. Love coding. So now we're going to do tplot, which is going to be equal to np linspace. Unfortunately, this I do not have extensive knowledge of. I just know that when you put all this together, it makes a graph. And then we're going to do H1 plot, H2 plot, H3 plot, and that's all going to be equal to res dot sol, and then tplot. Yep. And then we're going to do fig equals make subplots. And then we're going to start adding our scatter plots in. You would think that I would know that immediately after saying add scatter plots in. Anyway, we're going to set our x and y values. So and then we gotta name it. And we're just gonna do tank 1. Enter. And this is another one that we can just copy and paste. And then we just got to change these. Looks right to me. And now we're just going to tell our plot what to look like. So for the width, we're going to set that as 600. For the height, we're going to set that as 400. And then just to make it pretty, let's go ahead and make the template plotly underscore dark. Shift enter. Shift. Sorry.
So I obviously did something very wrong. But I have no idea what I did wrong. I don't know if this is going to make any difference. Why is it starting at 2000? So these are our outputs. So why are they so high? Invalid value in square root. Where? Did I do something wrong? This side should not be this high. And I don't know why it isn't. Why it is. Oh, right. There's something. That's... I have got to be doing something wrong here. And I think it... Just for the record, I'm looking at the whiteboard. So that's QN, AH. Where do we put the H now? Oh, that's where it starts. T and V, that's correct. I did something wrong with this. How about I just did this? I don't know if that makes any kind of difference. It breaks it. That's what it does. Oh, this has to be Q and not. There we go. Okay. So as you can see, it starts, the first tank's, anyway, as you can see, it reaches equilibrium right around, let's go ahead and change this to 3,500. That way we can see it a little bit better. Yep. So as you can see, that's what the graph looks like. All of them reach equilibrium right around there. And then just to show what they look like in steady state, pretty predictable, straight line. So they're all steady state. And then we can, but it's impeded by 25%, so 0.75 times that. Wonderful. I will see you in part B.